To solve by factoring, you need to know the zero product property. So basically, if the product is 0, one of the two factors must have been 0. So if they want us to solve by factoring, the first thing we need to do is factor. This is difference of squares. I can factor that w plus 3 times w minus 3. If you're not sure, you can always multiply it back out and make sure it works. So it's w squared minus 3w plus 3w minus 9. So, yep, we have w squared minus 9. My factoring worked. Okay, so back to where I was. I had w plus 3, w minus 3 equals 0. So using the zero product property, one of my factors must have been 0. So either w plus 3 equals 0. So then w equals negative 3. Or w minus 3 equals 0. So w equals 3. So those are our two answers. When I go to factor this, I'm looking for factors of 6 that give me a sum of 5. So factors of 6 that add up to 5 are 2 and 3. And when in doubt, you can always multiply it out. Does it work? X squared plus 3x plus 2x. Sure enough, it does. Okay, that was just me checking. Okay, now back to work. I have x plus 2 equals 0, or x plus 3 equals 0. If I subtract 2 from both sides, I get x equals negative 2. And if I subtract 3 from both sides, I get x equals negative 3. So those are my two answers. When we go to factor this next one, we're looking for factors of negative 35 that give us a sum of negative 2. So it's going to be negative 7 and positive 5. And again, I'm going to check by distributing. So x squared plus 5x minus 7x minus 35. Combine my like terms. Yep, sure enough it works. Now you'd probably usually just do that in your head, but I thought I'd show you. So back to our problem, we're going to have either x minus 7 equals 0 or x plus 5 equals 0. So we need to add 7 to both sides and subtract 5. And so our two solutions are 7 and negative 5. Another thing you could do to check is substitute back into the original equation and make sure it works there. Sometimes when we go to factor, we can just factor out our greatest common factor, which is what it looks like they already did for us here. So we're going to have either 3x equals 0 or x minus 6 equals 0, since they already factored. If I divide both sides by 3, I get x equals 0. Or if I add 6 to both sides, I get x equals 6. Yeah, this would be a nice one to check on. 3 times 0, substituting 0 in for x, would be 0, times negative 6 is 0. It worked. I'm going to try it with the 6 as well. 3 times 6 is 18, but 6 minus 6 is 0, so 18 times 0 is 0. So we just confirmed our two solutions are 0 and 6. Now a problem that ended like number 10 did would probably start like this one. So we would have to subtract 14x from both sides of the equation. Minus 14x if you need to show that part. And now my greatest common factor is going to be 2x. So if I divide that out of both terms, I'm going to have x minus 7 left. So now my mini equations, I'm going to have 2x equals 0 or x minus 7 equals 0. If I divide both sides by 2, x equals 0. If I add 7 to both sides, x equals 7. And let's come back here and check. So if I put 0 in, 2 times 0 and 0 minus 7, 0 times negative 7 is 0. And if I put 7 back in, 2 times 7 is 14, and 7 minus 7 is 0. So I know that both answers work. Okay, this time before we start factoring, I see a greatest common factor we could divide out of both sides, which is 4. So 4x squared divided by 4 is x squared. 24x divided by 4 is negative 6x. And 20 divided by 4 is 5. So I'm looking for factors of 5 to give me a sum of negative 6. They're both going to have to be negative, so minus 5 and minus 1. So then our little mini equation becomes x minus 5 equals 0 and x minus 1 equals 0. If we add 5 to both sides, we get x equals 5, and if we add 1 to both sides, we get x equals 1. And I'm going to check by substituting back into my original equation. So I've got 100 minus 120 plus 20 does equal 0. This one's easier yet. 4 times 1 squared is 4, minus 24 times 1 is 24, plus 20. 4 minus 24 is negative 20, plus 20 is 0. So I know that my two answers are 5 and 1.